Welcome to the video on line symmetry. This video will pick up where our discussion on line reflections left off. You will need a compass and a straight edge to complete this video, so if you need to, go ahead and pause the video right now, go grab your compass and your straight edge. First of all, what is a line of symmetry? I'm going to define a line of symmetry to be any line that can divide a figure or that divides a figure so that one half is a mirror image of the other. And the two examples that are given here in your notes, the butterfly, you can draw a line right down the middle so that the left half and the right half are mirror images of each other. And then a neat piece of artwork, you can draw a vertical line so that the left and right halves are mirror images. And you can also draw on this one a horizontal line so that the top half and the bottom half are perfect mirror images of each other. I can take the word wow and draw a line of reflection so that left half and right half are perfect mirror images of each other. All of those divide the figure so that one half is a mirror image of the other, and they are all therefore lines of symmetry. All right, let's go take a look at an example. It says in this next one, triangle ABC is reflected across line segment DE and maps triangle ABC onto triangle ABC prime. So in other words, if I input this triangle under the transformation that reflects across line segment DE, the output is triangle A prime, B prime, C prime. The first part of it says, use your compass and straight edge in order to construct the perpendicular bisector of each of the line segments that connects A to A prime, B to B prime, C to C prime. So in other words, each point in its image. So I'm going to go ahead and take my straight edge. I'm going to go connect point B to point B prime. I'm going to connect point C to its image, point C prime. And I'll connect point A to its image, point A prime. And I now have to grab my compass and straight edge and construct the perpendicular bisectors of each of those three line segments that I just drew. So you can either do this along with me, you can pause the video while we go through this, but on your paper also you need to go ahead and construct the perpendicular bisectors. And hopefully this will be a relatively quick construction for you because we did this a lot in the first unit. So there's my perpendicular bisector of segment B prime. I think I'll use a different color now to go construct the perpendicular bisector of C prime. Maybe I'll use green here. When I go to grab my straight edge, I notice that this perpendicular bisector is exactly the same as the one I drew for B prime. And then lastly, I'll go and construct the perpendicular bisector for segment A prime. This one I'll make purple. Well, and notice that my two purple arcs don't quite cross, so I have to go back and redo this so that it is indeed just right. There we go. Now I can use my straight edge to go ahead and connect. Excellent. So the next part says, what do you notice about these perpendicular bisectors? Well, I happen to notice they are the exact same. So they are all the same. And the second thing I happen to notice is they are all on the line of reflection. So that's kind of cool. All three of them came out to be the same. All three of them came out to be on the line of reflection. All right, the second part of this now asks us to label the point at which A prime, intersects line segment DE is point O. So there's A prime. There's the point right there that I want to label point O. What is true about the distance between A to O and the distance between O to A prime? Well, I know that they're the same. So the distance between point A and O is the same as the distance between point A prime and O. How do I know this? Well, point O is on the perpendicular bisector, and I know that every point on the perpendicular bisector is equidistant from each endpoint. That we learned in the first unit. And that's a big key idea that we're going to continue to revisit time and time and time again. Every point on the perpendicular bisector is always going to be equidistant from each endpoint. And the last part of this wants to know what is true about each point on triangle ABC and its corresponding point on A prime, B prime, C prime with respect to the line of reflection. Well, I'm going to say they will always be equidistant from the line of reflection or the perpendicular bisector. And I could either say line of reflection or perpendicular bisector because they will always be one and the same. So either one will work in that case. All right, some properties you need to know about what happens whenever we reflect a figure across a line. And I'm going to say these are strictly reflection properties. There's some special things that happen whenever we reflect a figure over a line. There are certain things that don't change, that remain the same. And I'm going to use a fancy word for that and call it invariant. So properties that are invariant, and that word invariant is going to be a key vocab word for us this year. Invariant means either that they're preserved, they don't change, they stay the same. So here's some properties that are going to remain unchanged or invariant under a line reflection. Number one, distance. So distance remains the same. The distance from between 2 points in the pre-image is going to be the same as the distance between those corresponding points in the image. Number two, angle measure. Something that's a 90-degree angle in the pre-image will also be a 90-degree angle in the image. Parallelism is another property that remains invariant. In other words, if two segments are parallel in the pre-image, they will also remain parallel in the image. Collinearity, and that's a big fancy word. It's one that I hope you know. If you don't, now's a chance to kind of get on board with us. Points that are collinear in the pre-image will also be collinear in the image. By collinear, I mean points that are all on the same line. So if they're all on the same line to start with, they'll still be all on the same line once that figure or that image is reflected. And then the last thing that's preserved is midpoint. So if you have something that's the midpoint in the pre-image, then that's also going to remain the midpoint once that object is reflected. There's one property, however, that is not preserved. And hopefully you already know what this one is. And if you don't, I'm going to give you a minute to think about it. Think about what happens when you look at letters on a word in the mirror. The property that's not preserved is orientation. The orientation in the image is always going to be opposite whatever the orientation was in the pre-image. And you know that, just like if you look at your reflection in the mirror, you notice that everything is backwards because that orientation has been reversed. All right, I'm going to go ahead and jump up to the top of the next page. This says steps for drawing the line of reflection. This too, you need a compass and you need a straight edge for. So I'm going to say use your straight edge. And you're going to use that straight edge to connect any point in the pre-image to its corresponding output or its corresponding point in the image. And it's important that you use 2 points that are corresponding. The one that was put in has to correspond with the one that came out. In step 2, construct the perpendicular bisector of the line segment that you drew in step 1. Because again, that perpendicular bisector is the same as the line of reflection. That's a big idea for today's lesson. All right, so down in these examples, I'm going to need to drag my compass out. You should grab yours as well. Number 1 says construct the line of reflection across which the image below was reflected. So this is going to be really important that when I go to grab my straight edge, I have to connect the input and the output. So in this particular case, segment or point A, when we reflected it across this line, the output was A prime. You could use A prime, you could use E prime, B prime. Any of those are valid line segments. The important thing is here, you get the pre-image and the image that correspond to each other. So I'm simply going to go construct the perpendicular bisector of line segment A prime. I don't know if that arc is going to be big enough, but we'll see. Oh yeah, go Mrs. McCann. And it doesn't matter which 2 points you pick, the perpendicular bisector will come out the same for both. And if I wanted to get fancy and snazzy, I could mark all those congruent pieces. This is the perpendicular bisector, making those two the same. Perpendicular means right angles are formed, so I could label those right angles. But in any case, this perpendicular bisector is my line of reflection. I'm trying to get way too fancy here. Let's get rid of that. And we'll try that again. Line of reflection. And if at this point you want to turn the video off, you can go ahead and shut the video off. If you feel like you want to walk through another one together, let's go tackle number 2 together. So this one is a little bit different, but the key ideas remain exactly the same. The idea is to connect any point in the pre-image with its corresponding point in the image. So I don't know, you can pick any line segment that you want to. I'm going to go connect this bottom of the M that's right in the middle to its corresponding point in the image. So that guy right there. he's the one I want to construct the perpendicular bisector for. But you could have done this one to this one. Any of those corresponding points will make you a success. So I'm going to have to extend my compass a little bit in order to construct this perpendicular bisector. I can go ahead and put my compass away, grab my straight edge. And there's my perpendicular bisector. If I wanted to get fancy and snazzy, I can label these two segments the same. And I can label my right angles right there at that point of intersection. But my line of reflection here is the same as the perpendicular bisector. As always, my deepest thanks and appreciation for the gift of your time. If, as always, you have questions or concerns, or I said something in the video that doesn't make sense, please either shoot me an email or jot it down in the notes or in the margin of your notes so that you can remember to ask the next time you come back to class.